Hello, everyone, and welcome. I'm Matt Brandon, class of 92, and Associate Vice President for Alumni Engagement and CEO of your William & Mary Alumni Association. Thank you for joining us for another program in William & Mary Alumni Association's Lifelong Learning Series. Many of you joined us last month for the first session of our AI for All program. In that session, we explored the fundamentals of artificial intelligence, what AI is, how it works, where it excels, and where its limitations lie. For those of you who are unable to attend that session, you can find the recording on the William & Mary Alumni Association's YouTube channel. Today, rather than focusing on the concepts behind AI, this session is all about putting those ideas into practice. Whether you are drafting emails, brainstorming ideas, planning a trip, or learning something new, AI can help you work more efficiently and creatively. Today's webinar will feature live demonstrations of some leading AI tools, practical prompting techniques, and real-world examples that you can begin applying in your personal and professional lives. We're fortunate to have two outstanding guides for today's conversation: Dean Doug Schmidt, the inaugural Dean of the School of Computing, Data Science and Physics, Sciences and Physics, and Dr. Dan Runfula, the Chair for William & Mary's Data Sciences Department. Together, they bring both a strategic perspective and the hands-on expertise needed to help us move from understanding AI to using it effectively. Before we get started, I'd like to mention a couple of housekeeping items. Today's webinar is being recorded and will be made available on the William & Mary Alumni Association's YouTube channel for those who would like to either revisit the demonstrations or share them with others. We will have some time for Q&A after the demonstration, so we encourage you to submit those through our webinar using the Q&A panel. And by we, I mean Dr. Schmidt and Runfula, do our best to answer as many questions as possible during our discussion. Thank you again for joining us today and for your continued curiosity, engagement, and support of William & Mary. We hope today's session gives you practical skills and the confidence to begin using AI in ways that enhance your work, your learning, and your everyday life. And with that, please join me in welcoming Dean Schmidt and Dr. Runfula.
Great. Thanks so much, Matt, for the introduction. Welcome, everybody. Some of you who were here before, welcome back. I'm Doug Schmidt, and today I have the privilege of being joined by my colleague and friend, Dan Runfula, who's the chair of the Data Science Program and Department here at William & Mary. So here's our pictures. Let's jump in without any further ado. So we're going to continue the discussion we started last time about the democratization of computational thinking. And this time, we're going to take a focus on showing how to apply various tools to do AI-augmented problem solving. Brief recap of our tutorial from last time. If you are interested, you can watch this, as Matt said earlier, at the link that's available at the bottom of the screen, or you can just search for it online. There were 7 major topics we discussed with respect to computational thinking. We talked about logic, being able to figure out what the steps are, what the decision points are. Talked about decomposition, breaking big problems up into smaller pieces. We talked about pattern recognition, looking for recurring themes that you can reapply in different contexts. We talked about abstraction, separating out what's important at a given level from some things that are just implementation details, basically trying to focus on the what, not the how. We talked about design, which is about trying to figure out what components you need and how they interact with each other. We talked about automation, which is really what AI is particularly good at, about trying to enable humans to let the machine do a lot of the busy work and the heavy lifting and implementation details for them. And finally, something else that's just super important is verification, making sure that we're confident that the results are actually meaningful and correct. So last time we'd taken a look at a media creation package tool using Google Opal, and this time we're going to take a look at some different applications. When I start thinking about how to use I think about what I do day to day in my work, both as a dean at William & Mary, as someone doing research, as someone who teaches courses and gives talks, and in other things, just my basic daily life. So I do a lot of work with visual storytelling, teaching, writing, knowledge synthesis, ideation, developing ideas, creative thinking, and strategic thinking. And what I try to do is I try to apply the 7-dimension computational thinking process we just talked about in order to find ways to make my daily life more effective, more creative, while still remaining ethical and responsible. And what I typically find is two types of things. I end up being able to use AI to do problem solving, doing that paradigm we just talked about. And I also have increasingly started to use various scalable agentic tools, which further optimize different steps in my daily workflow. In today's tutorial, Dan and I are going to focus primarily on AI augmented problem solving. And then we'll be discussing the scalable agentic tools in much greater detail in our next tutorial. As always, when you start thinking about using AI, the goal is to try to get results that are as accurate and trustworthy as we can. And what I've found, and what Dan and I will both talk about today, is you need some robust methods and tools to make this work effectively. So using the right AI tools, the right AI versions is very important. We'll talk a bit more about that. We saw there were some questions about that. We'll be happy to answer those in detail when we're done. Something else that's important is looking for recurring ways to prompt the AI so you get results that are meaningful. And Dan will talk at length about a very nice paradigm he has come up with to think more systematically about how to do the prompting. It's also important as part of that to provide context. As I walk through my first example, as Dan walks through his examples, you'll see how context plays a very important role to give the AI tools the right perspective when addressing certain problems. There's no substitute, even with the advent of AI, for critical thinking. We want people to still make sure they use their big brains so that they can make sure that the results are going to be effective and meaningful. And of course, that segues into verification, which we often do manually, often by double, triple checking sources, going back and looking to find the basis for why the AI said what it did. Modern AI tools are getting much better at being able to provide you with traces of where that came up with the ideas and suggestions that they generate. So that's very important. And if you apply all these things, you're much more likely to have output you can have faith in, have trust in. But of course, we always have to verify and only then trust. And the purpose of all this, of course, is to try to minimize the amount of hallucinations or confabulations that AI may do, and basically to maximize the trustworthiness of the output from what are inherently non-deterministic AI tools. So without further ado, let's take a look at an example. So this is an example of something I did in my daily life. I find myself often having to organize groups of people to get together to work and brainstorm as a team. So several years ago, we had 35 professors at a computer science faculty retreat, and we wanted to organize them into 5 discussion groups with exactly 7 professors per group. So that was kind of the overall theme. So I'm going to talk about how we ended up doing this. And first, I'm going to talk about how we would have done this before we had AI. So before we had AI, what we would have done would have solicited ideas from the faculty, perhaps collected them through emails or maybe a Google Doc. And then we would have taken all the topics the faculty wanted to talk about, and we would have clustered them manually into discussion groups. So if we wanted 35 faculty to be in 5 discussion groups, we would have sat down by hand and we would have clustered those topics in various ways. So we would have said, what are we going to need to do in order to come up with, say, 5 topic areas? And that would have been something we would have done. Then what we would have probably done is generated a Google form manually. I'll talk more about what a Google form is in a minute, but basically it's a simple way of being able to query or survey a group of people to get their perspectives or their choices. And from the Google form that we would have generated, we would have then come up with faculty ranking the choices that they wanted to. We would have had maybe 5 groups, and then the faculty would have ranked the interests in the topics, maybe their top 3 in order 1, 2, 3. And once we had their desired topics, we would then have gone ahead and manually assigned them to 5 discussion groups, and then the groups would have discussed the topics at the retreat. And if this sounds laborious, it would be. It's very difficult. It's not impossible, but it's just very tedious and error prone to sit down and try to do all these steps by hand. So, of course, the good news is with the advent of AI, we can now automate many of these steps. So we can get some ideas from faculty. We can cluster the topics with AI. We can generate a Google form automatically with AI, so we don't have to do anything manually. Faculty still have to go and use the Google form to rank their choices. But then once we get what they want to be part of, we can use AI to automatically assign the faculty into the groups, giving them their first choice if possible, their second choice if all the first choices are full, and then going to the third choice if nothing else is available. And then they can go ahead and discuss at the retreat. Now, the discussions that would take place would be the same whether we do this manually or with AI. But by using AI, it's going to go a heck of a lot faster, as indicated by the hourglass and how quickly it drains on the right. So what I'm doing here and what I'm about to walk through in detail illustrates the use of so-called no code, I don't have to write any code, computational thinking that allows us to map these 35 professors to the 5 discussion groups. And we're going to take a look at this in 2 stages. First, I'm going to walk through at a high level what I did at each of those steps and visualize what we did and what it looked like. And then I'm actually going to walk through ChatGPT to show you exactly the prompts that I used each step along the way and what the results were. And as you'll see, it's a great example of AI augmented problem solving. So let's start by the first task, which is to solicit discussion topics. To do this, we made it pretty straightforward. We used a Google Doc, which is basically like a shareable Word document that multiple people can go in and edit and add what they want to have discussed at the faculty retreat. So as you can see, we collected about 25 different topics, 1 topic per person who contributed their thoughts to what they wanted to cover. What we then did is we used ChatGPT to cluster or group these topics together and then create a document. In this case, it would be a document like a Word document or just output in a table form that illustrates what the 5 discussion groups are by working bottom up from the topics people suggested. It'll automatically summarize what that group is going to discuss, and then it'll show the mapping back to the topics that existed in the original Google Doc. In other words, the 25 different themes that people wanted to discuss, topics that the faculty wanted to discuss. And you can see ChatGPT does a very, very good job at this. One of the groups was building a stronger faculty community and infrastructure. There was also a group about reimagining graduate education and research excellence. There was a group that was focusing on enhancing undergraduate student experience. There was a group on curricular innovation and the future of computing education, kind of looking further down the road than just what we're doing at the time. And then finally, there was a group that looked at strategic growth, identity, and student success. And this was built bottom up from ChatGPT, as I'll show you in a moment. Now, we could have gone in and edited this. It didn't have to be those 5 topics, but I thought that those 5 topics did a good job of characterizing the themes that faculty expressed interest in when they did their Google form. What we then did is we took the output of ChatGPT and we asked it to generate a Google form that the faculty could use to indicate what topics they wanted to focus on. So each faculty member would indicate their name, and then they could order what topics they wanted to cover from 1 to 3. And the idea here, of course, is to allow people to decide what it is that they want to be doing. Now, the other neat thing about this was that form that you just saw was actually generated automatically by ChatGPT from the output of the summaries it created. And I'll show you the prompt that I used to do that. But basically what you're seeing here on the right is JavaScript code, which is what's used to generate the Google form itself. Then each user uses the Google form and it records their name and their choices. And you can see here, it collects the responses. So what is shown here in the histogram at the bottom is that most faculty's preference, first topic, most high priority preference was for enhancing the undergraduate student experience. Second most interested topic of the faculty was reimagining graduate education and research excellence, and so on and so forth. And there were fewer people who were interested in strategic growth, identity, and student success. Now, what's neat about this with Google Form is it'll actually generate a spreadsheet in what's called a comma separated value form. And so for each faculty member, it'll indicate what their interests are for those various topics. And so we collect that automatically. So we didn't have to do that. That's what's done by the Google form. And now here is where it gets really fun. What we do is we use ChatGPT to generate a mapping of the professors to the discussion group topics, like building a stronger faculty community and infrastructure, or reimagining graduate education and research excellence, and so on. And it'll put each faculty member into the appropriate group. And so I'm showing you here how it does it by group, so you can see each faculty member by group. And it also indicates whether the person got their first choice or not, or whether they got their second choice or their third choice. And then you can also ask ChatGPT to generate this by person instead of group. So here we have each of the various faculty members, what their group assignment is, whether they got their first, second, or third choice, and other kinds of information to give them a sense of what's happening. So there are different ways of being able to group these things, and you can have ChatGPT do all this for you. So the neat thing about this was that ChatGPT yielded a solution very quickly without the need to manually write any code or really do any analysis in depth by human effort alone. So a manual coding approach would have taken hours to do, if not days. In contrast, the no-code reasoning using AI to do the problem solving finishes in minutes. And this is a great example of how ChatGPT can collapse coding complexity into conversation. So just to recap what we saw, we applied decomposition to figure out the various steps we needed to have. We figured out what logical steps were needed at each phase. I looked for certain patterns which I could reuse in other parts of my use of AI. We abstracted away all the details of deciding how to do the mapping, how to write the form for the Google form, write the code for the Google form, how to do all the clustering of various things. And design and automation were also handled by AI. And finally, I did the validation, although AI helped at certain points by being able to make sure the faculty were properly allocated into the right groups according to their choices. So what I'm going to do now, and then I'll turn it over to Dan for his example, is we're going to quickly go through the conversation with ChatGPT that generated all these results. So I will move out of this and go over to my web browser. And so what you're seeing here is basically my session with ChatGPT. I can probably expand it a little bit so it's a little bigger. And the first thing I did is I took that file containing the ideas and the topics to discuss, and I asked it to cluster all the entries, there were 25 entries, into 5 discussion groups, and then give each group a description of what its purpose was, and then summarize the focus of the group. And you can see it chunks away for just a couple seconds and quickly spits out this summary with those 5 groups. And you can see it also came up with a summary of what each group's focus was, and then it mapped back onto the various topics that were in the original Google Doc. So we could see a mapping from what was the input to what it had summarized and collected and clustered. And that gives a little bit more explanation. The next thing I did is I said, please generate some code, some JavaScript code to create a Google form. And I want this Google form to be entitled Discussion Group Selection. And that will allow the faculty members to rank their interest in participating in up to 3 of the 5 discussion groups that ChatGPT identified. And then I told it what I wanted the form to look like. So you have to give your name, then you get a multiple choice grid, and then you can tell it what you want the choices to be. And I said, use the titles from the discussion group as the columns, as the rows, and make the columns be the 1, 2, 3 decisions. And here's what this looks like. This is what the the form actually looks like if we were going to go ahead and fill it out. You can see you have to put your name in, and then you just click on the radio dials to the selection dials to indicate what your choices are for each of those topics. So in pretty much no time at all, 13 seconds, way faster than I ever could have done this by hand, it spit out the JavaScript code to do all of this stuff. And then I cut and pasted that JavaScript code into the Google Apps script editor, and I pressed run, and it created that particular Google form. So once again, I'm really doing no implementation details. I'm just describing what I want to have. So after people went out and then responded to the form, you can see that here's all the people who responded, and here were the results. And I can then come along and download the results in comma separated value form. And then I take that comma separated value form and I gave it to ChatGPT. So here's the results. Here's the comma separated value form for the choices that the faculty want. And here's where it gets really fun. I said I attached a comma separated value file for 35 faculty members containing their top 3 topic preferences ordered from highest to lowest out of 5 topics. And I said, please generate an output that allocates all these 35 members to 5 topics, balancing them evenly, taking their ordered preferences into account if they don't get their first or second choice, and also give preference to faculty in the order they appear in the CSV file, because that was the order in which they'd responded to the survey. And it thought for 19 seconds this time, way, way faster than I ever could possibly have done this by hand, and it generated output. And interesting about this, it tells me it was balanced, which is what I asked for. It was ordered according to what the faculty wanted, and preferences were honored as much as possible. However, there was one little quirk. Almost everybody got their first, second, or third choice, but one faculty member didn't get what they wanted. It did because the way the things were allocated, the way the topic preferences were specified, it turned out that the initial algorithm that ChatGPT used in response to my fairly general prompt didn't end up allocating one person. And it told me who got what. So then what it did, it said, I could do better. I could do an optimal assignment. And so I said, please suggest how I could improve my prompt so that you give me a better result. You give me a result where everybody gets what they want. And it gave me some feedback. And this is really fascinating. I am now using AI to tell me how to use AI better. And so what it does is it gives me an updated prompt. This is a prompt more like a data scientist or a computer scientist would have written, as opposed to my initial prompt, which was really kind of high level. It was just me thinking as a layperson, how can I do this in an automated way? And so now it's refined the prompt so it's much more precise. And it will be able to allocate everybody to one of their preferences. So it told me something else. It said, treat this as a constrained optimization problem rather than a greedy assignment. Its initial approach was to use a greedy assignment because I hadn't given enough detail. And here's the cool part. I then just said, please apply your improved prompt and generate the results. And it went off, and this time it thought a little longer. It thought for 40 seconds, not 19 seconds. And it came up with a solution where everybody got a topic that they were interested in. So 28 people got their first choice, 6 got their second choice, 1 person got their third choice, and nobody got a choice that they didn't want. And so then it shows me the new ranking. This is the new output, but I wanted it to be in a different format. So I said, please generate the output in Microsoft Excel form. And so it thought for almost no time at all, and it gave me the results here in this Excel file. And then it said, but I could generate a more polished version if you would like. I said, sure, please generate the more polished version. Boom, it went out and generate a new version that used color coding to indicate more things. And then finally, I said, please regenerate the polished version, but organize it so it's easy to see what the results are. And so I wanted it to have the faculty member name first, followed by the topic number, the discussion group name, and so on and so forth. And it does that. And here you can see, if we can open it up, and this is indeed the spreadsheet that it generated. So you can now see that. I showed this earlier, but now you can see what it actually generated. So the cool part about all this is I just had to tell it what I wanted it to do, and it did all the heavy lifting itself. So let me wrap up now, and I'm going to pass it off to Dan. Here's just a couple other things for those of you who weren't here the first session. I have a YouTube channel where you can learn lots more about AI. So please feel free to take a look. And if you'd like to learn more about how to do effective prompt engineering, I highly recommend you check out my colleague and friend Jules White at Vanderbilt University, who has, I think he's got something like 3 dozen massive open online courses on Coursera that are free that talk about many issues related to prompt engineering and using generative AI. So with that, I'm going to stop and pass it off to Dan.
Thank you very much, Doug. Let me get myself started here. All right, can you all see my slides?
Yes.
Wonderful. So hello, everyone. I'm Dan Runfola. I'm the chair of the Department of Data Science here at William & Mary. And today I'm going to be talking a little bit about how to generate prompts that are not just effective. So I think Doug just showed you a really effective and interesting way to use AI, but prompts that are also reliable. Prompts that when you give the prompt to a generative system, it will tend to give you back the same or a very similar response. This has been something that's been driving a lot of both research and kind of operational need on our side when it comes to AI tools. A lot of people are reticent to use AI because when you interact with these tools, the responses you get are somewhat different each time by design in some of these models. So we really want to constrain that. We want to figure out how can we actually make sure that when we train someone how to use AI, when we're teaching students how to use AI, that they'll get the same answers time and time again. So to go through this, I'm going to follow an approach similar to Doug. I'm going to go through one motivating example, and then I'll briefly show you what the output looks like on ChatGPT. Now, in my case, by design, we're just going to have one prompt. We're not going to be iterating back and forth with the tool. We really want to find a prompt that will give us the solution we want the first time and then every time after. So the example I'm going to use is an example drawn directly from our own needs here at William & Mary. So as a department chair, I somewhat regularly have staff that will join my department or leave my department. They might move to another unit at William & Mary, and so I have to train the new staff that come up through my unit. This is a problem we all have at all sorts of different institutions. And we see kind of common patterns that when we don't do a good job of that. And as a chair, I've certainly run into these problems. I'll have a new administrator start, and I will give her or him all of the material. I'll give them access to their shared inbox. I'll give them a big folder full of documents and policies, their calendar, a bunch of notes that I might have. I'll sit down with them and kind of talk through what their day-to-day tasks look like. But invariably, by the middle of their first week, they're going to be looking through the documentation I provided them and realize that there are 2 different spreadsheets that both track how many PhD students we have, or there are 3 different documents that describe our policy around tuition reimbursement. And so come the end of their first week, what are they doing? Well, they're creating their own documents to summarize for themselves what's going on. So we end up with these inefficiencies. We end up with even more copies of these documents each time we go through this process. So what we've been experimenting with is how we can use AI to actually mitigate this problem. And it turns out AI is fantastic at helping with these handoffs between employees, or even when we have employees just moving into new roles here within the department. So you can imagine there's lots of different data types that need to come in to facilitate these handoffs between individuals. You've got the obvious stuff. So your inbox history, right? All of the emails that you've sent. You have the information on your calendar, all of the old products, templates, examples, reports that an employee has created, their contacts and their trackers, their to-do lists, right? All of that's normal. But then in addition, when we have these handoffs, certainly at a large state agency like William & Mary, there are a lot of informal and unknown rules that help my employees do their jobs. So things like, if I need to get something complicated done, who in procurement do I talk to? Because they're creative. Or how do I figure out how to process a specific type of grant for an undergraduate? Who's the right person in undergraduate employment to talk to answer these specific types of questions? That information exists. If you go through email chains, you can use AI to actually unpack in very specific situations how a former employee would have effectively approached the problem. And if we can extract that effectively, we can use that information for new employees so that they can more seamlessly slip into their roles. And we're beginning to see some success here. So what I'm going to use within that context, that motivating example, I'm going to talk about how we teach students how to use AI in a way that is reliable and consistent. So what we're going to do is a little bit different from what Doug just did. We're going to build one prompt that's probably going to be longer than most prompts you've seen before. This will be a prompt that is a few paragraphs of information that will provide very explicit guardrails to our generative AI model that tells it not only what we want, but also things we don't want, how we want it to behave, the type of persona we want to take on, a lot of details that you wouldn't normally assume you need to give to an LLM. You might not have to, but if you want consistent results, it can be very, very valuable. To do this, there's generally 5 different parts, the anatomy of these prompts, that we'll actually be going into. And I'm going to walk through each one of these in some detail. We'll construct an example of each one of these components, and then we'll run that example through ChatGPT. So these 5 topics here, so we have our context. So this is defining the big picture of kind of who is our audience, what is the goal. Our inputs, which are specifically any data that you want the algorithms to process. So in Doug's example, the inputs would have been the initial Google form or the initial Google document that submitted all the ideas of what they wanted to discuss. The rules, so this is kind of the bounds that we want the AI to operate within. The specifics of the output that we want. And very interestingly, something that's very valuable is any checks that we want the AI algorithm to run. So we'll go into each one of these now. So first, let's talk a little bit about context. So literally, if you look at the left here, you'll see at the bottom left, there's this highlighted section of this slide. That example prompt where we have context and then a bunch of sentences after it, that is verbatim what we will end up copying into ChatGPT or Gemini or Claude or whatever your preferred tool is. We're going to be explicitly using the word context, explicitly describing what it is. Now, when we talk about context has a few key questions that we want to make sure that the AI algorithm can answer. So things like, who is going to use the output that I'm going to generate? What decisions will it support if it is a decision product? What tone should it use? Is there anything it should avoid doing? Now, these contextual rules are critically important because of the way that LLMs work. So there's a sizable amount of research that shows when you have LLMs, they pay a lot of attention to what comes first in a prompt and what comes at the end of a prompt. The longer the documents get, the longer your prompts get, the more weight is going to go on the front and the back of those prompts. And so in this context thing, this is the very first thing that the LLM is going to see when we provide it with instructions. So it will provide very firm guidance to whatever the algorithm is going to do. To do this in this particular case, so we're going to take this motivating example of the transition from one employee to another, and I'm going to narrow the scope of that just a little bit. So I want to go through their email inbox. I want to go through their contact lists. I want to go through their calendar. I want to go through all of the documents they've provided. And I want to extract from all of that any and all contact information that I can to give the next employee that's coming in a good guide map as to who to contact when. So in this example, we're going to have a few key things that we're going to be trying to include in this contextual portion of our prompt. We want the end product. So in this case, a follow-up contact list. The audience. So the audience would be a newly assigned employee, a manager, an administrator, whatever that employee role is. The tone. So this is a professional document. This is not a fictional piece, so we want to specify that. And I always like to specify in my context no-go words, things I do not want the algorithm to include. So if you look at the highlighted example prompt here, you can see what this kind of breaks out into. The context, I'm creating a follow-up contact list. So putting right at the very front the instructions as to what I want for a newly assigned manager, so the target audience. So that first sentence you want to have include both of those factors, very important. The goal is to identify people and organizations and explain why each matters in my role. So trying to make sure that the algorithm understands what the goal is again, using a clear professional action-oriented style and avoid vague wording. So all of this helps the algorithm constrain again exactly what it's going to be doing. Now the next portion of this same prompt, so we're literally going to go to a new line and we're now going to very explicitly define what inputs the model will receive. So what am I actually going to give it? And this is, again, for consistency, very important for the model to have a common understanding of all of the different files that it may receive, all of the different types of data that it may receive. Because if you don't provide that information, then it's going to guess. So as an example, if you uploaded a zip file of all of the different documents from your department or your program or your business into ChatGPT and you said, search through this for all of the contacts that you can find, what ChatGPT will do is it will try to pick and choose and guess what's most important and what's less important, and it will end up missing a lot of the potential information within that corpus of data. Conversely, if you tell it where the emails are, where the calendar is, where the contact lists might be, it can prioritize more effectively, just like a human employee would do. So we want to give it that information. So here we have a few key questions we want this input section of our prompt to address. What sources are you actually sending? Are you uploading to the tool? How will the information you send actually be labeled? What information should be ignored? And what sources should be ignored? And so I'm going to walk through kind of which one of these, what these mean here in a second. Let's take a look at the example prompt and how this actually plays out. So under inputs, I will upload a zip file, so just a collection of a lot of different files containing email excerpts, calendar entries, and shared folder notes. So the algorithm is now expecting 3 different types of data. Emails are in the folder email inbox and defined with a JSON, a JSON file. That's a type of email file if you export from Outlook, for example. Calendar is in a folder called calendar, and meeting notes are in a folder called meeting notes, right? So very explicitly defined what the algorithm is getting because I don't want it to guess. Critically, treat only text I provide as source material. So as you are all well aware, having heard anything on the news in the last 2.5, 3 years, hallucination is a huge problem when it comes to AI tools. When you're providing data to an algorithm like this, it really wants to fill in the gaps. And so if it was able to find, for example, a name, but not an email address, or a name, but not a phone number, the algorithms are generally inclined to make up an email address or make up a phone number. By explicitly saying, treat only text I provide as source material, it inhibits, doesn't preclude, but it inhibits the algorithm from creating and hallucinating those additional facts. Also interesting, you'll notice that the word only is in all capital letters. There's been a non-trivial amount of research that indicates having emphasis like that can cause some LLMs to treat those words with more authority. So it is more likely they will pay more attention to this instruction. So that's why that's like that. That's not true for all models, but it is true for some. Finally, you'll see kind of this bigger question of what in those sources should be ignored. So that's what's in the purple down here at the bottom of this section. So in this case, ignoring signatures, disclaimers, repeated headers, formatting artifacts, unless they contain contact information. So this is helping the algorithm not include all of the data that I upload. I know there's a lot of spurious information that I'll be providing to the algorithm, and the more data it has to process, the more likely it will miss critical things. And so this is to try to reduce the scope of what it will need to do. The next section of our prompt is going to focus on rules. So these are guardrails and ways to restrict outputs in very specific ways. This will help to, again, prevent algorithms from making judgment calls and thus prevent them from hallucinating. So key questions here that we might want to answer. If you're creating a spreadsheet, what becomes one row? Very explicitly want to define that. What fields of data that I'm trying to populate might be unknown? What rows should be allowed to merge? How do I handle duplicate information? And when do I block guesses? So we'll walk through again this example. So the rules, Use one row per distinct person or organization. So as we go through the AI algorithm and ingest all of these emails, I want every row to represent one person my new employee might have to contact. And I want to make that explicit within the algorithm, because otherwise it's going to guess. And it could guess, well, maybe one row should be an office that your employee might want to contact and the contact information for that office. That's not what I want. And I want to constrain the algorithm so that no matter what, it will give me the same outputs. Extract only stated facts. Again, we want to mitigate the ability to hallucinate. Write unknown when a field is missing. So this gives the algorithm not only permission, but instruction when it does not know information to flag that. And this again heavily helps to mitigate hallucination. Some rules for merging rows. So if we have duplicate information, when do we actually allow the algorithm to merge those rows together? We don't want it making that choice itself. And then finally, and again, to mitigate hallucination, do not infer relationships, titles, emails, or phone numbers from the context. We always want it to only pull out a phone number if it sees the verbatim phone number in the records it is provided with. So this mitigates that challenge. Next, we want to very explicitly specify to the algorithm the output that we want. So here we want to be, again, as careful as possible to constrain the algorithm in all the different ways that we can. So questions we might want to ask here: what format do I need? What columns are required? What order reduces cleanup? And what should appear after the table? And so I'll talk about that last one here in just a moment. And let's again work through what this prompt might look like. So an output. In my case, I wanted a table. Markdown table is just a type of table. You'll see it in a moment. It's for websites with columns. And I'm going to explicitly tell the algorithm what I want those columns to be, because otherwise it will make it up itself. Name, role, organization, last time they were contacted, the individuals, their contact information, the description of why they would be important to me, the evidence that the algorithm has to support the information in that row, and critically, I want the confidence of the AI algorithm. I want the AI algorithm to actually tell me how confident it is in the information that it provided within a row. Because if I'm going to rely on that information in my job, I need to know how confident the extraction tool was. And so I can go and fix the table if I need to. I can then go into more detail too on explicitly what type of confidence I want. So in this case, I'm requesting a confidence level of the AI of low, medium, or high based on the quality of the evidence that it finds. And really critical, this is something that I always recommend that you put into prompts, is this final sentence. After you create the table, after you create the product, whatever it is, include a short review list with duplicates, conflicts, and missing critical details. So this will force the algorithm to go back and actually search back through the table to find errors it might have missed. Finally, the last component of our prompt here is going to be a check. So the check is kind of a last step look back across the entire product that was just created to actually try to identify any errors that might have manifest through the process. Frequently in modern LLMs, so if you go to ChatGPT or Gemini, this is actually done using agentic tools where there may be a separate model altogether that does a final check. So it's really, really helpful to include this. It forces a second pass. Things that we might ask about here are what mistakes would matter. We want to specify it to look at those types of mistakes specifically. What types of rows need evidence? When should a human review my data? And how should conflicts be handled? We want to specify all of that. So as an example here within the prompt, before finalizing, review the table for likely duplicates, one problem I care about, stale details, unsupported claims, conflicts between sources, missing critical fields, and low confidence rows. So these are all the types of errors I, as a user, care about. I want to make sure that's what the algorithm is looking for. Do not silently resolve conflicts. If there is a conflict, the AI algorithm will want to fix it itself. This is telling it, don't do that. Instead, resolve those conflicts and tell me that they are there. Flag rows that need human review and explain the reason briefly. So we'll have the algorithm actually tell us what is wrong. So we can put this all together. We can put this all together into a full contact list prompt. And literally, this is just everything we just went over copied into one big prompt. And what we're going to do is we're going to take this entire prompt and we're going to upload the entire thing at the same time into a tool like ChatGPT or Gemini, along with the data sets that we wanted to analyze. Now, critically, you want to put all of this in at the same time, right? The algorithm needs to know what the context, inputs, rules, output, and checks are. You don't want to input these one at a time because it wouldn't actually give the same type of, wouldn't elicit the same type of behavior from the AI algorithms. And what this actually will result in, here, I'll swap real briefly here. Can you guys see my chat GPT now?
Yes, we can see it, Dan.
Wonderful. So this is exactly that. So this right here is a copy and paste of the context, output, all of the different sections that we just made a moment ago. I've uploaded a zip file of emails and the calendar entries and meeting notes, exactly what I had said I would. And what you can see is the ChatGPT outputs gives you this nicely constructed data set, which gives me all of the contact names, their role, when they were last contacted, their email address, description of why they would be important, and then evidence, like the actual evidence that the algorithm found. This has been anonymized, but the same basic idea. If you scroll to the bottom of the table, then also as requested, we get this wonderful output of what's wrong, right? What types of things were confusing to the algorithm so that it can then be subjected to later human review. Now, the final thing I'll show you very briefly here before I think we have a little bit of time for Q&A is just to give you a taste of what this looks like when we move to the agentic side. So this was wonderful, very helpful for our incoming employees to give them this list. But by adding just a few tweaks here and there, we can actually turn this into a website that allows new employees to then dive into all of the documents automatically that they might need. So we actually have online portals now that allow us to construct to facilitate these types of handoffs where individuals can see what follow-ups might existed, all of their contacts, the documents, open questions, all sorts of useful information. And I think we'll probably be talking a little bit more about how those agentic frameworks can be used in our next session. So with that, thank you guys very much. And I believe, Randy, am I handing it off to you?
Yeah, that's perfect. Thanks, Dean Schmidt and Dan, for the demonstration. So we do have a few minutes here for Q&A. Start off with one of the questions that was submitted. Actually, there were several questions submitted in the same vein here as part of registration, talking about, as a beginner, if free AI models are an appropriate starting point, or if there's a platform that you would recommend. Actually, one of the questions submitted here in the Q&A said you both use ChatGPT over Claude. Do you think there's one tool that's better than the other? And if so, which one should you be using?
Dan, why don't you talk about your experience with Claude and ChatGPT, because you've been using both?
Yeah, absolutely. I think a lot of what I'm most interested in is how to make sure that the prompts that we're writing make it so it doesn't matter what tool you use. It's constantly changing. Claude may be ahead one week, ChatGPT may be ahead the next week, and Gemini the next. It's also really dependent on the task you're working on. Right this moment in time, like literally this week, I'm having more success with Codex with ChatGPT for coding and more than Claude, and I'm having better experiences with Claude for writing than I am ChatGPT. That was the opposite like 2 weeks ago. And so really what I'm trying to do is teach students, teach everyone, how can you write prompts in such a way that it minimizes the difference with respect to what tool you use. On the free versus paid, I do see tremendous differences between the qualities of those outputs. I think that using the free version of AI tools really gives you a false impression of their strengths and weaknesses. The paid versions are far more impressive right now. Doug, you want to build on that?
Yeah, to amplify Dan's point, this is a shifting sands. I think most people conclude that ChatGPT and Claude are really in the pole position. Gemini comes in after that, and Microsoft Copilot still has work to be done to be useful. It's more for people who are doing simple editing, word processing kinds of things than really doing deeper analysis and research. The other thing to keep in mind is even with the free versions, they'll often give you a chance to do what's called deep research. And if you really want to take 10, 15 minutes to crank away on something and examine it more thoroughly, that's the way to go. You'll get much more accurate results, and you'll also get results where it'll show where it got the information from that it used to make its decisions. I would say, however, to amplify Dan's point, if you're serious about using AI, get the $20 a month version at the very least. You'll find it's much better. And even those things are getting ridiculously good at a very fast pace.
Thanks. So next question was submitted here. Somebody recently asked ChatGPT to create a case study on a very specific topic, asking them to create 20 slides in PowerPoint with product visuals. While ChatGPT provided a slide response, response was basically saying this is what you should do for each slide. It didn't actually create the PowerPoint or create the visuals. Is there a way to get past that?
Dan, you've been using that, so tell us now with Codex.
It depends on what tools that you're using. So how I've actually kind of built my workflow around creating slides is using specifically the ChatGPT, what used to be called Codex local app. That will create both assets and slide decks for you simultaneously. Now, that said, I have struggled mightily with the quality of the content that ChatGPT and Codex will create when it comes to slide decks. The workflow that I most commonly use now is I will sketch out my own slide decks using only text, upload those slide decks into a tool like ChatGPT, and I will say, make this look decent. So it's very quick for me to just put in the titles for every slide, the bullets for every slide, and then use something to kind of beautify those slides. But creating the content from scratch, I have also struggled quite a bit with.
I have colleagues who've done a fairly good job using either Claude or Codex for generating slides. My particular style, as you see, if you look at my slides, is highly visual, and I have my own particular format I like to make my slides in. I use ChatGPT along with other tools to make most of the visuals, including images and videos and so on. But I'm still kind of driving the show. But everybody has their own idiosyncratic way of doing this kind of stuff. So I encourage experimentation.
Thank you. Next question. So another user, they're using ChatGPT to support a large public policy initiative involving legislative research, data analysis, AI applications, communications, and stakeholder engagement. They say as the projects grow to dozens of interconnected topics, what organizational strategies have you found most effective for managing that complexity within ChatGPT while also preserving context and making information easy to retrieve?
Dan?
Yeah, so this is something that we're actually actively doing some research on as a part of some funded projects. There's lots of different strategies out there. The most common one is, of course, RAG-based structures, where you have different topics in different chat threads, but those chat threads are accessible through external RAG interfaces, so that when you're talking in other threads, you can still reference those source threads. That's been somewhat useful for us, but largely only in custom environments. Those aren't the types of things that we can roll out in like the ChatGPT licenses that we have. Those are things that we've been doing kind of locally at William and Mary. The other strategies that we've been doing have been much more uh, simple. Things like just spinning off copies of chats so that people are kind of working on their own workspaces to avoid context overrides to try to keep, to ensure that there's only really critical information in one chat thread. But I would say right now, the tools themselves around those very large projects are nascent. I've not seen really great solutions to this problem yet, other than things we're trying to cook up in-house.
Thanks. Another question, and this was brought up a lot during our last session, is security and privacy concerns, such as data protection for clients or letting AI access credentialed sources, and as was brought up in the demonstration, is giving AI access to your emails or calendars and stuff like that. So, what information should people never put into AI tool, and what are some of the biggest privacy and security concerns that they should understand?
So I just shared my screen again because I had accidentally shared my screen earlier. And in preface for this problem, you don't have to run things in the cloud. So I think the examples we just gave were through ChatGPT, but there's very easy. So LM Studio, which I'm showing on my window right now, completely free. If you have a GPU or a recent Mac computer, you can run LLMs locally, and you can do everything locally. It never leaves your computer. So you can export all your emails, your calendar, whatever you want. So I think there's a false presumption that AI needs to involve security types of problems like that. That's not true. You just have to use your own resources to do it to mitigate those problems. Now, there are trade-offs today. You don't get the best and most, brightest models when you go down that road, but you get complete privacy. And there's huge trade-offs. There's value to that.
Complete privacy as long as your computer doesn't get hacked. But I understand.
Yes.
If you're using a cloud-based version, like the retail version you'd get with Claude or ChatGPT, a simple rule of thumb you might want to follow is don't put anything into a cloud-based AI system you wouldn't be comfortable emailing to the wrong person. So think carefully when you put stuff in there because chances are it could end up in other places. So this includes stuff like confidential client information, unpublished research, proprietary source code, student records. We're very conscious of that at universities because of FERPA requirements, for example, personally identifiable information, passwords or AI keys, medical or financial records. Be very, very cautious. There, of course, are ways you can use enterprise licenses, which will give you a bit more security. But if you're really paranoid about that kind of stuff, then it's best to follow Dan's advice and run a LLM, an AI model locally on your computer.
Thanks. And we got time for one last question here. It's actually a couple different parts. So there are a lot of submitted questions about the ethical use of AI. So one of that is when you generate something using AI, who owns it? Is it you or the company that owns the AI model? And when is it considered plagiarism?
So ownership depends on the AI platform's terms of service and applicable copyright law when it matters. Some countries don't apply copyright to AI, some do. Most major commercial AI systems allow users to own or use the content they generate, but you should always check the platform's terms of conditions. Plagiarism is a different story, of course. This is something that is true whether it's written by AI or not. If you are copying someone else's words verbatim without citing them properly, or you're paraphrasing incorrectly, then you're possibly running afoul of plagiarism guidelines and standards and so on. But that's a broader issue than just the use of AI. Of course, we have to be careful, especially for courses where assessment is based on writing, programming, essays, those kinds of things. And a lot of people would like there to exist some tools that will definitively determine whether something was written by AI. They're very, very difficult to use unless someone does something ridiculously stupid like cut and paste a screenshot that says generated by ChatGPT. So I think what you need to do is think about transparency. When you use AI, acknowledge it appropriately. Many professional societies now have guidelines on how to use AI in the production of various manuscripts or books or papers and so on. And just like you would acknowledge a coworker who contributed something or proofread your article, for example, you should think about AI in the same way. But these are shifting standards. And for example, just recently, the Association for Computing Machinery, which is responsible for a lot of the journals in computer science space, has decided to no longer query the authors to disclose use of AI in producing their papers. They just assume people are doing it, and it was getting to be sort of farcical because people were doing it and they weren't acknowledging it, and so they just gave up. So we need to be prepared for a world where more and more content will be generated by AI, and it's harder and harder to tell what is and what isn't. If you really want to scare yourself, there's a wonderful TV show from England called The Capture, which is kind of like Black Mirror, and it describes a world where you can basically fabricate video and audio in real time, and it's very scary, and we're getting dangerously close to that world right now.
Hey, Doug, with that, one of the questions submitted too was, are there any tools that the public can use to help identify if an email, website, commercial, image, whatever, is generated by AI?
There are a variety of tools that can do this, but unfortunately, as I said, they're not perfect, and people have to be extremely careful when you try to use them, because if you use them and you accuse someone of using AI and you cannot prove it, these tools, by the way, are probably not going to constitute proof in a court of law. You're most likely opening yourself up for a lawsuit. And so a lot of universities are being very, very careful how they're accusing people of using AI because it has a tendency to backfire and can actually cause more harm than good. So I think it's better to get accustomed to a world where not everything is written by a human, and we have to get better at sifting out the wheat from the chaff.
Thanks, Doug. That's all the time we have for Q&A. As we wrap up the program, Dean Schmidt, is there anything else you want to add for your closing comments?
Thanks so much for coming, Dan. Thanks for providing that really cool example of showing how to use AI more trustworthy in a trustworthy way with a single prompt. That's fantastic. And Dan and I are going to come back probably in another month, and we'll talk a lot more about using agentic systems, agentic orchestration, agentic platforms to go a step further and automate even more of the steps in doing the kinds of things we just talked about. So please come back again, and feel free to reach out if you have any questions.
Thanks, Dean Schmidt and Dan, for the demonstrations on how we can use AI in our everyday lives. And thank you all for joining us today. Special thanks to the Alumni Association and the Lifelong Learning Series for making programs like this possible. As a final reminder, a recording of today's webinar will be available on the William & Mary Alumni YouTube channel within the next week, and we'll email the link out to those who registered as soon as it is posted. Thank you again for your continued support of William & Mary and your commitment to a lifelong learning. Have a wonderful day.